Generally, the subpanel amperage should be determined by the load it will carry. According to the National Electrical Code, a subpanel can handle up to 80% of its maximum capacity. In this case, a 100 amp subpanel can handle up to 80 amps of load. For a second story with 10 circuits, the total load is likely to be less than 80 amps. Therefore, a 100 amp subpanel is not too large. The concern may stem from the potential for overloading the subpanel in the future, but this can be mitigated by proper load planning and the use of breakers to protect the circuits. There is no rule against installing a range on the second floor, but it does require additional precautions. The National Fire Protection Association requires that a range be installed on a non-combustible floor or on a floor protected with a non-combustible material. In a second floor installation, this may require firstly reinforcing the floor to support the weight of the range and appliances, secondly installing a non-combustible countertop or base cabinet under the range, and thirdly providing proper ventilation and clearances to prevent heat buildup and fire hazards. Before installing the subpanel or range, it's essential to perform a load calculation to determine the actual electrical load requirements. All wiring must comply with the NEC and local electrical codes. All electrical work should be inspected by a licensed electrician and approved by the local authority. Let's delve deeper into subpanel sizing. The 80% rule mentioned earlier is a critical aspect of the National Electrical Code. It's in place to prevent continuous overloading of the subpanel, which can lead to overheating and potentially fires. Continuous load is defined as a load that operates for 3 hours or more at a time. The 80% rule means that the total continuous load on a breaker or subpanel should not exceed 80% of its rating. So, for a 100 amp subpanel, the continuous load should not exceed 80 amps. To accurately determine the load in the subpanel, you need to perform a load calculation. This involves adding up the amperage of all the devices and appliances that will be connected to the subpanel. It's essential to consider both the general lighting and receptacle loads, as well as the specific loads of appliances like refrigerators, microwaves, and any other significant power consumers. For general lighting and receptacle circuits, the NEC specifies a minimum load of 3 volt amps per square foot. This means you need to calculate the square footage of the area served by the subpanel and multiply it by 3 to determine the minimum load for lighting and receptacles. For appliances, you need to use the nameplate amperage rating. This rating is typically found on a sticker or plate on the appliance itself. If the appliance is rated in watts, you can convert it to amps by dividing the wattage by the voltage. For a standard 120 volt circuit, the formula is amps equals watts divided by 120. For a 240 volt circuit, the formula is amps equals watts divided by 240. Once you have calculated the load for each circuit, you can add them all up to determine the total load on the subpanel. It's important to note that you don't necessarily need to add up the full amperage of every circuit. For example, if you have several lighting circuits, you can apply a demand factor to account for the fact that not all of the lights will be on at the same time. The NEC provides demand factors for various types of loads. After performing the load calculation, if the total load is less than 80 amps, a 100 amp subpanel is adequate. However, if the total load is close to or exceeds 80 amps, it's recommended to install a larger subpanel to provide more capacity and prevent overloading. Now let's talk about installing a range on the second floor. As mentioned earlier, there is no specific rule prohibiting this, but there are several safety considerations to keep in mind. Firstly, the floor must be able to support the weight of the range and any associated appliances. Ranges can be quite heavy, so it's important to ensure that the floor structure is strong enough to handle the load. If you're unsure, it's best to consult with a structural engineer to assess the floor's capacity. Secondly, the range must be installed on a non-combustible floor or on a floor protected with a non-combustible material. This is to prevent the floor from catching fire in the event of a spill or other mishap. Non-combustible materials include concrete, tile, and metal. If the floor is made of wood or another combustible material, it must be protected with a layer of non-combustible material, such as cement board. Thirdly, proper ventilation is essential to prevent heat buildup and fire hazards. Ranges produce a lot of heat, so it's important to ensure that the area around the range is well ventilated. This can be achieved by installing a range hood or other ventilation system. The ventilation system should be vented to the outside to remove the heat and fumes from the kitchen. Fourthly, proper clearances are required around the range. The NEC specifies minimum clearances between the range and combustible materials, such as walls and cabinets. These clearances are designed to prevent the combustible materials from catching fire. Refer to the range manufacturer's instructions and the NEC for specific clearance requirements. When wiring the range, it's important to use the correct size wire and breaker. Ranges typically require a dedicated 240 volt circuit with a breaker size of 40 amps or 50 amps, depending on the range's wattage. The wire size must be large enough to handle the amperage of the range without overheating. Refer to the NEC for the correct wire size for the breaker size and distance. It's also important to use the correct type of receptacle for the range. Ranges typically use a 14-50 receptacle, which is a 4-prong receptacle designed for 240 volts appliances. Make sure the receptacle is properly grounded to prevent electric shock. Finally, all electrical work should be inspected by a licensed electrician and approved by the local authority. This will ensure that the work is done safely and correctly and that it meets all applicable codes and regulations. In addition to these safety considerations, there are also some practical considerations to keep in mind when installing a range on the second floor. Thusly, it may be more difficult to run the electrical wiring and gas piping to the range on the second floor. This may require additional labor and materials. Secondly, it may be more difficult to vent the range hood to the outside on the second floor. This may require running the vent duct through the attic or roof. Thirdly, it may be more difficult to move the range to the second floor. Ranges are heavy and bulky, so it may require special equipment and extra manpower to move them upstairs. Before installing a range on the second floor, it's important to weigh these practical considerations and determine if it's the best option for your situation. Now, let's elaborate on the load calculation process for subpanels, providing more detail and examples. Load calculations are the cornerstone of safe and compliant electrical installations. They ensure that the electrical system can handle the intended load without overloading, which can lead to overheating, damage to equipment, and even fires. The NEC provides detailed guidelines for performing load calculations, and it's essential to follow these guidelines carefully. The first step in performing a load calculation is to determine the general lighting and receptacle load. As mentioned earlier, the NEC specifies a minimum load of 3 volt-amps per square foot for general lighting and receptacle circuits in dwellings. To calculate this load, you simply multiply the square footage of the area served by the subpanel by 3. For example, if the second story of your home is 1000 square feet, the general lighting and receptacle load would be 3000 volt-amps. This is a minimum value, and you may need to increase it if you have a lot of lighting or receptacles. Next, you need to calculate the load for any specific appliances that will be connected to the subpanel. This includes appliances like refrigerators, microwaves, dishwashers, washing machines, dryers, and ranges. For each appliance, you need to use the nameplate amperage rating to determine the load. If the appliance is rated in watts, you can convert it to amps by dividing the wattage by the voltage. As mentioned earlier, the formula for converting watts to amps is amps equals watts divided by volts. For a standard 120 volt circuit, the formula is amps equals watts divided by 120. For a 240 volt circuit, the formula is amps equals watts divided by 240. For example, if you have a refrigerator with a nameplate rating of 120 volts and 5 amps, the load would be 600 watts. If you have a range with a nameplate rating of 240 volts and 40 amps, the load would be 9600 watts. Once you have calculated the load for each appliance, you can add them all up to determine the total appliance load. It's important to note that the NEC allows you to apply demand factors to certain appliance loads. A demand factor is a percentage that represents the amount of time that an appliance is actually in use. For example, a refrigerator is not running constantly, so you can apply a demand factor to reduce the calculated load. The NEC provides demand factors for various types of appliances. After you have calculated the general lighting and receptacle load and the appliance load, you need to add them together to determine the total load on the subpanel. This is the total amount of power that the subpanel will need to supply. Once you know the total load, you can determine the appropriate size for the subpanel. As mentioned earlier, the subpanel should be sized so that the total load does not exceed 80% of its rating. For example, if the total load is 70 amps, you would need a subpanel with a rating of at least 87.5 amps. In this case, a 100 amp subpanel would be adequate. It's always a good idea to oversize the subpanel slightly to provide some extra capacity for future expansion. This will allow you to add more circuits or appliances without having to upgrade the subpanel. In addition to the load calculation, it's also important to consider the voltage drop in the wiring. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire. Voltage drop can reduce the performance of appliances and cause them to overheat. The NEC specifies maximum voltage drop limits for various types of circuits. To minimize voltage drop, it's important to use the correct size wire for the length of the circuit. The longer the circuit, the larger the wire size that is required. The NEC provides tables that specify the minimum wire size for various circuit lengths and amperage ratings. It's also important to use high-quality wiring and connections to minimize resistance. Resistance is the opposition to the flow of electricity. Resistance can cause voltage drop and overheating. By following these guidelines, you can ensure that your electrical system is safe, compliant, and reliable. Now let's address some common misconceptions about subpanels. One common misconception is that the subpanel size must match the main panel size. This is not true. The subpanel size should be determined by the load it will carry, not by the size of the main panel. Another misconception is that you can simply add up the amperage of all the breakers in the subpanel to determine the total load. This is also not true. The total load on the subpanel is determined by the actual amount of power that is being consumed by the circuits connected to the subpanel. This is why it's important to perform a load calculation. A third misconception is that you can use any type of wire for a subpanel. This is not true. The wire used for a subpanel must be sized correctly for the amperage and voltage of the subpanel. It must also be rated for the environment in which it is installed. A fourth misconception is that you can install a subpanel yourself without any electrical knowledge. This is not recommended. Electrical work can be dangerous, and it's important to have the proper training and experience to do it safely. It's always best to hire a licensed electrician to install a subpanel. Let's move on to some additional considerations for installing a range on the second floor. Gas ranges require a gas supply line. The gas line must be installed by a qualified gas fitter and must comply with all applicable codes and regulations. The gas line should be sized correctly for the BTU rating of the range. It should also be tested for leaks before being put into service. Electric ranges require a dedicated 240 volt circuit. The circuit must be wired with the correct size wire and breaker. The circuit should also be protected by a ground fault circuit interrupter, GFCI, to prevent electric shock. Both gas and electric ranges require proper ventilation. The ventilation system should be vented to the outside to remove the heat and fumes from the kitchen. The ventilation system should be sized correctly for the size of the range and the kitchen. Ranges should be installed on a level surface. This will prevent the range from tipping over and causing damage or injury. The surface should also be non-combustible to prevent fire hazards. Ranges should be installed with the proper clearances from combustible materials. This will prevent the combustible materials from catching fire. The clearance requirements are specified in the range manufacturer's instructions and in the National Electrical Code. Ranges should be inspected by a qualified appliance technician after installation. This will ensure that the range is installed correctly and is operating safely. When selecting a range for the second floor, it's important to consider the weight of the range. Some ranges are heavier than others, and the floor must be able to support the weight of the range. It's also important to consider the size of the range. The range should be sized appropriately for the size of the kitchen. When installing a range on the second floor, it's important to take extra precautions to prevent water damage. Water damage can occur if there is a leak in the water line or if the range is not properly sealed. To prevent water damage, it's recommended to install a water leak detector near the range. It's also recommended to seal the range to the floor with a waterproof sealant. Finally, let's talk about the importance of electrical inspections. Electrical inspections are an essential part of ensuring the safety of your home. Electrical inspections are typically required whenever you make significant changes to your electrical system, such as installing a new subpanel or range. The purpose of an electrical inspection is to ensure that the electrical work has been done safely and correctly and that it meets all applicable codes and regulations. During an electrical inspection, the inspector will check the wiring, the breakers, the receptacles, and other electrical components to make sure that they are installed properly and are in good working condition. The inspector will also check to make sure that the electrical system is properly grounded. If the inspector finds any problems, they will issue a list of corrections that must be made. It's important to make these corrections promptly to ensure the safety of your home. Electrical inspections are typically performed by local building inspectors or by private electrical inspection companies. The cost of an electrical inspection varies depending on the size and complexity of the electrical system. However, the cost of an electrical inspection is well worth it to ensure the safety of your home. By following these guidelines, you can ensure that your electrical system is safe, compliant, and reliable. It's always best to consult with a licensed electrician or other qualified professional if you have any questions or concerns about your electrical system. Let's summarize the key points. Firstly, subpanel size should be determined by the load, considering the 80% rule. Secondly, load calculations are essential for proper sizing. Thirdly, second floor range installations require careful consideration of structural support, non-combustible materials, ventilation, and clearances. Fourthly, always comply with the NEC and local codes. Fifthly, electrical inspections are crucial for safety. By adhering to these principles, you can ensure a safe and functional electrical system for your home.